Hey everybody, welcome to the weather breakdown. Today is January 4th, the second video of the year. Now, in our previous video, we've talked about the onslaught of a serial cyclogenesis regime, washing away or potentially washing away the cold that's currently centered over Europe. Today, we're going to see if that still holds true and then drill a little bit deeper. We'll take a closer look at the large-scale Atlantic setup and how repeated deep lows are being generated over the ocean and what this means in terms of windiness, storm potential, and high impact weather across the northern Atlantic and deeper into Europe. Let's dive straight in, see how the weather looks like today using the chase buddy that I have created with the two friends of mine, and then move over to the weather charts. See you there. So, if we look a little bit at how our weather charts look like today, we have a series of low pressure centers here, which doesn't change from yesterday. Still have our low pressure center here over the Iberian Peninsula, which was originally here, and we mentioned it was going to migrate towards the east. It has already been migrating towards the east, so we have that. We still have our original airflow moving here around the low, moving like this, and around this complex regime we have our frigid air moving over the warmer sea bodies, leading to convection. And as you can see here, there is some wintry precipitation over the Benelux going on, which is a mixture of rain and snow, and even full-blown snow, leading to some accumulations there. This regime where this air is moving towards the south, and this air circles around the low towards the north, still set up a frontal boundary here, which is connected to a low pressure center, as you can see here. There's another low pressure center here, which has this large sloping frontal boundary over the northern Atlantic. There's another low pressure area just outside the domain here. And as you can see here, by the spacing of the 500 millibar height contours, there's a jet maximum here moving in that direction, meaning that these systems of low pressure centers will start to migrate towards the northeast and the north as well. And we've mentioned yesterday that there is a high pressure area here, as you can see here. And this high pressure area, due to this predominant north-south directed air and this low pressure center moving towards the north, that this high pressure center will start to migrate towards the south. And you can actually already see that happening here, right? You can see that the MSLP field is starting to be elongated towards the south. And you will see that high migrate further and further and further towards the southeast, which will have massive implications on the large scale Atlantic flow. And it's this Atlantic flow that we are now going to delve a little bit into and what this means in terms of weather over Europe. Okay, let's dive straight in. Now, if you look at our weather chart, we have the same thing. We have our complex low pressure system here, diverting air from the north over the warm ocean bodies, leading to wintry precipitation over the Benelux and Germany, parts of the UK as well. We have our low pressure center here, which is migrating towards the east. This sets up a flow regime like that while this air is moving southward from the poles, creating a frontal boundary like this. We've already identified in our observations also that there is a jet maximum here due to the 500 millibar height contours being packed together. This means that the systems here will start to migrate towards the northeast, pushing this high pressure area further south, as we've already identified in our previous video and as we touched upon today as well, right? So let's see actually what's happening. I'm going to erase everything. If we go forward, we can see that high pressure area starting to migrate towards the south. As it migrates toward the south, you can see that the warm conveyor belt here of this system here, the warm conveyor belt of the system here, starts to reorient itself more towards the east. You can see that happening here. If I go a little bit further, you can see the reorientation happening, okay? And this is where the serial cyclogenesis regime starts. We have here low number 1. We have in its wake low number 2. We have in its wake low number 3. You can see the same thing in the European model. We go a little bit further, you can see this high pressure area situated here, reorienting the warm conveyor belt into more zonal orientation. We go forward, we see here low number 1. We see here low number 2. We see here low number 3. We see here low number 4. We see here low number 5, and so forth. Okay. Now, we've already identified, or we've talked about it yesterday, that this will have implications on the temperature field. So if we move a little bit forward with the temperature field, let's stay with the European model for now. If we go forward, you can see low pressure center, a high pressure center moves in that direction, as we've already identified here. It came from this location, it moved towards there. Right. We go forward now, we can see that reorientation happening in the temperature gradient here. In this temperature gradient, you can see that happening. And along that temperature gradient, you can see a low pressure area forming. If you move forward in time, we see that low pressure area. See how packed those isobars are together. We're going to delve into it a little bit later because it's pretty significant. If we go forward, we have low 1. We have low 2, and while all these lows are bashing the European mainland, you can see that the boundary for the cold was originally here, is moving that way. It will keep moving further and further and further east as these lows start to crash into the European mainland. You can see that here now already, the freezing temperatures are now oriented that way. If we go a little further and further and further, you can see this bashing continuing, meaning that the colder temperatures, they will start to be pushed to the east due to the western circulation and the serial cyclogenesis having these impulses towards the European mainland. If we look at the system here, there's like one impressive system here. Look at this one here. You go like this, check what's happening here. We're going to delve a little bit deeper into that one. Okay. If you go a little bit further now, and I will immediately pull up the wind gusts because they are pretty significant. If you move a little bit further, you can see the low pressure area starting to manifest itself. And as you can see here, the speed at which this low pressure area forms and deepens brings a massive wind field along the channel. So the coastal regions of Normandy and Brittany and Le Nord in France, also the south coast of England, they might see some very heavy wind gusts with this system. If you go a little bit to the central Western Europe, zoom in, you can see that these are wind gusts exceeding 150 kilometers per hour. So this is in the range 150, flirting with the 160 here. If you go a little bit further, you can see that low scouring over the channel. So this is a very, very, very impressive system. And this means that we can expect, if this holds true, we can expect a lot of damage around this region here. But we'll see what happens in the next runs. If we go a little bit to the American model predicts more or less the same, as you can see here. This is that low pressure system, but it's situated more north and it doesn't have this maximum wind field. What it does have, however, is it also has this rapid deepening of the low pressure system. Because if you go here, we have 1004. If you go to 24 hours further, like 1, 2, 3, 4, 5, 6, 7, 8, right? You can see that it deepened from, what is it? From 1000 more or less, it deepened to 76, 72. 70, so 970 millibar deep low going from 1000. This is a 30 millibar drop. If you go to with the European model, we can see the same. It deepens very impressively, and the speed at which it drops leads me to think that we are dealing with a rapid cyclogenesis case here. More sensationally put, we are dealing with a bomb cyclone here. And I wouldn't be surprised if these values keep up, that there will be a sting jet being manifested over the channel, but we'll see in the future how that goes. If we step a little bit back and we go a little bit further, let's take the precipitation type. We said yesterday that there was going to be a snowy intermezzo that is going to affect the European mainland here. If you go a little bit further, we can still see the wintry precipitation due to the convective nature of this air mass here. If you go a little bit further, you can see that tomorrow, a frontal boundary with some snow, it passes, and then we have a bigger one here coming here, this system. And as you can see, it has a very elongated frontal zone with snow signals here. And that snow will continue to move into the European mainland. And as you can see, there's another impulse of snow here with a massive snow dump for the northwestern part of the Alps. So for the people who want to go skiing, be careful what you wish for. If you go a little bit further, you will see this low pressure center, and you can see the massive, impressive frontal slope here, like this, the occlusion there and the warm front there, right? If you go a little bit further, you can see all these systems going to bash the mainland with other impulses of precipitation. But as you can see, as time and time progresses, the snow signals start to disappear. Why? Because we've already mentioned this. The Atlantic circulation brings in milder and milder air, not allowing the precipitation to fall as a frozen precipitation type. Now, what we need to be aware of is that the trajectories of all these lows as they move over the ocean is of crucial importance. The track of these low pressure systems can make all the difference in the world between windy or calm conditions, rain or snow, precipitation or even dry conditions. Now, we'll keep monitoring how this evolves, especially the rapid cyclogenesis cases that both GFS and the European model are hinting at. Now, these models will start to converge anyway somewhere throughout the week, so we'll keep you updated as this merging process happens. It might also even be a good opportunity to explain the term rapid cyclogenesis to you guys, but I do not know whether I will have enough time to do a deep dive on the topic. What I will promise you is I will do my best to explain the topic as we move along throughout the week. Okay, so with that, I will leave you for this video. I hope you liked it and see you in the next one. Bye, everybody.